Welcome to The Explainer. Today we're diving into a really crucial scientific assessment of our planet's circulation systems. Those massive networks of wind and water that basically define our climate. We're going to treat this like an investigation, not just into how our planet is warming, but whether it could suddenly just snap into a totally new state. All right, so let's just jump right in with this fundamental question. We almost always talk about climate change as this gradual, slow, steady warming, a slope we're climbing. But what if that's not the whole story? What if some parts of our climate don't just bend, they break? What if they could literally snap into a new state all at once? The source material we're digging into today explores that exact idea. It suggests that some of Earth's biggest systems, we're talking ocean currents, atmospheric patterns, might have these hidden switches. Scientists call them tipping points. And we're not talking about small, gradual changes here. These are fundamental and maybe even irreversible shifts. So our investigation begins. What exactly are these hidden switches? How do they work? And most importantly, what's the evidence that they even exist? First things first. Before we can go out and find them, we need to know what we're actually looking for. What does it mean for something to be a tipping point? Okay, so here's the key. A tipping point isn't just a big change. It's when a system gets pushed past a specific limit, and then it just takes over, driving itself toward a completely new state. The change becomes self-sustaining. So how does that happen? Well, the engine behind all this is something called a positive feedback loop. The best way to think about it is like a domino effect. You give it that first little push, right? That triggers a reaction. But, and this is the important part, that reaction doesn't dampen the push. It actually amplifies it, which then creates an even stronger reaction, and so on and so on. The system basically starts running away on its own. To figure out the risk, scientists use a confidence rating system. It's kind of like how an investigator would work a case. If you have one clue, that's low confidence. If you have multiple clues that all point in the same direction, that gets you to medium confidence. But when you have consistent evidence from lots of independent sources, we're talking models, historical data, direct observations, that's when you can say you have high confidence. Okay, time to open our first case file. We're heading into the deep ocean to look at the prime suspects for this kind of tipping behavior, the huge circulation systems that move water all around our planet. And first up is the big one, the AMOC. Now, this isn't just some current. It's a colossal system, like a planetary-scale conveyor belt that carries warm water north and cold water south in the Atlantic. It is so powerful that it helps regulate the temperatures for the entire northern hemisphere. And this shows you the stakes. It's a really stark contrast. On the left, you've got the AMOC as we know it. It's in its stable on state. But on the right, that's a potential off state if it were to tip, and the impacts would be just enormous. We're talking severe cooling across Europe, monsoons disrupted all over the globe, and massive shifts in weather patterns. So, what's the verdict on this one? Well, the evidence from past climate records is pretty clear. The AMOC has switched abruptly before. We also know there's a key positive feedback, this thing called the salt advection feedback, that could drive it. And to top it off, some recent studies suggest we might be seeing early warning signs of instability right now. So, the classification? A tipping system with medium confidence. Next up, we have a system that's related but different, the North Atlantic subpolar gyre. Just try to picture this giant swirling vortex of cold water just south of Greenland. It's absolutely critical for sinking dense water into the deep ocean, and it has a direct impact on the weather in Europe. Now, a really crucial point from the research is the estimated warming threshold for its collapse. The best estimate is sitting around 1.8 degrees Celsius of global warming, a level we could get pretty close to in the next few decades. Seeing a number like that, well, it really puts the urgency of all this into perspective, doesn't it? All right, let's head to the other side of the planet. The Antarctic overturning circulation is the second great branch of this global conveyor belt. Down there, the ocean creates the coldest, densest water on the entire planet. That water then sinks and drives deep ocean currents, which helps regulate Earth's total energy balance. And the concern here is definitely growing. This quote from the source material says it all. Evidence of its ongoing decline has escalated in recent years, both from observations and numerical models. So this isn't some far-off prediction. It's a statement about what's happening right now. The data and the models Both show this system is already getting weaker, and that's why it gets classified as a tipping system with medium confidence. Okay, let's close the ocean file for now and move to our second case file. Now we're looking up into the atmosphere to examine the complex and, in some cases more debated, potential for tipping points up there. The West African monsoon has an absolutely incredible history. I mean, if you look back, you find evidence of a green Sahara, a lush green landscape, all powered by a much stronger monsoon system. But then, around 5,000 years ago, that system flipped, and it did so abruptly, switching to the dry desert we know today. What this tells us is that the system can exist in at least two very, very different stable states. So, because of this dramatic past and the fact that there's a strong feedback loop between vegetation and climate, it gets classified as a tipping system. But there are still a lot of uncertainties here, which is why the assessment is made with low confidence. Now let's turn to a name we've all heard, El Niño. This is one of the most powerful climate phenomenon on Earth, period. And this chart shows a really clear trend from the model projections. Under those high emission scenarios, the most extreme El Niño events, well, they're expected to happen a lot more often. But, and this is a really important distinction to make, having more extreme events doesn't automatically mean the system has a tipping point. The current evidence suggests that while El Niño is going to get more intense, there isn't some threshold where it will suddenly and irreversibly flip into, say, a permanent El Niño state. So for this one, the verdict is not a tipping system. So, after going through all the evidence from our two case files, the oceans and the atmosphere, what's the final verdict from this whole scientific investigation? This summary table really lays it all out for us. You see the major ocean circulations, AMOC, the subpolar Gyre, the Antarctic circulation, all classified as tipping systems with medium confidence. The West African monsoon is also on the yes list, but with lower confidence. And then there's El Niño, where the evidence points away from tipping behavior. It really seems like the greatest risks are lurking deep in the oceans. So here's the bottom line. The science is pretty clear that some of these absolutely critical systems can tip. Now, the exact thresholds, that's still a huge area of research, but the risk itself is not theoretical. And that leaves us with this final, urgent question. It's not just about knowing that the cliff edge exists, it's about understanding how close we are to walking right off it. And that is the challenge ahead.